Okay, so we are going to be working on angle conversions today, from degrees to radians and radians to degrees. But like I mentioned earlier, before I started recording, I want to just go over what a radian measure is. Again, a radian measure definition is not something that you have to understand in order to do this homework. Okay, even if you didn't understand it, you can still do the homework just fine. Okay, so if you're still a little lost after it, I mean, we could talk about it later, but it's not 100% necessary for you to know it. Okay, but let me just introduce it for you, so that way you guys can kind of understand where the term radian measure came from. So first off, let's talk about degrees. This is something you guys should be pretty, I guess, well acquainted with a degree measure, right? So for example, if I draw something like this, okay, most of you guys will be able to say that looks like a 45-degree angle, right? If I draw something like this, what angle am I trying to draw for something that looks like that? Whoops. Yeah, most of you guys say like, oh yeah, that's a 90-degree, right? If I were to draw a line that looked like this, and I draw my angle measure like that, how many degrees is that? That's 180, right? So 180 degrees. So you guys kind of are familiar with this stuff here. Here's one more just to kind of go over some of the basics. If I start from here and go all the way around, how much is that? It's in the 300s. 360, right? 360 degrees. Okay? Now, those are really good things to know, degrees, but once you get to trig and calculus, we say, oh, let's not use degrees anymore. Let's change over to radians. And we're like, oh, okay. So obviously this is pi over 4, and this is pi over 2, and this part right here is pi, and this angle is 2 pi, right? Everybody's going to understand that. But in reality, people don't understand how we get this. Like, how is it that 90 degrees is pi over 2? Pi is 3.14. If you divide it by 2, it equals to like 1 point something. It's not 90. How does that make any sense? Okay, so let me explain to you guys where the idea of a radian came from, okay? And then after I do that, then we'll get to our main lesson, okay? But since this is a lesson that talks about radian measures, it makes sense to maybe introduce the where it came from idea, okay? So the radian measure. The radian measure came from circles. Okay, so let me see. I want to get that. So we're going to start off with the circle. Now what I'm going to do is I'm going to draw its center. Okay, and I'm going to draw a radius. Okay. Now, sneak peek, radius is the radian measure, just so you know. But what I'm about to draw right now, do not draw, okay? Don't draw it. If I were to grab that line, the radius line, if I were to grab that with my fingers and like pluck it out and put it straight up like this. Now don't draw this, okay? And say that's still R. Okay? And then I bend it so that it touches the circle. So instead of it looking like a straight line, it's going to look like that. So now you can draw that if you want. Okay? And I'll draw another line here. We'll call that R again. All right, that little blue line, or that blue curve that I created by using my radius, but I bent it into the shape of the circle, that is called 1 radian measure, Okay, this is 1 radian measure. So a radian is the distance that's the same distance as a radius. It's one distance on a circle that measures the length of the radius. Okay, that's a radian measure. It's this curve that measures the length of the radius. Now, how many of these blue curves do you think it takes for me to go around the whole circle? If you had to guess. 5? About 5? Maybe 6? Maybe, well, 7 I think might be too many. Right? The number of little radian arcs is 6.28. That's how many it takes. 6.28 of them. So how did they figure that out? Well, they said, all right, what if we go ahead and construct it, right? So they started, I'm going to kind of do this just freehand really quick. And they said, okay, so that's 3, 4, 5, 6. And then they said, wait a minute, we got this little gap. How much is that little gap? Okay, and they found out it was 0.28. Okay, now they did this mathematically, but by them trying to figure this out, they actually came up with the formula for us. Anybody know what the circumference of a circle is? The formula? Anybody remember? There's a pi in it. Well, that's the value of pi, but what else is next to it? Anybody remember? Circumference is 2 pi r. Okay? That's the circumference of a circle. If you want to figure out how much distance there is all the way around a circle, you do 2 pi r, the radius of your circle. Now remember, r is our radian measure. In other words, to go all the way around the circle, we're going to take 1 radian, r, 2 pi times that. What is 2 pi? So pi is 3.14. If I multiply it by 2, I get 6.28. So your circumference is 6.28 times r. In other words, they're saying it takes 6.28 radian measures to go all the way across, or all the way around a circle. Okay, all the way around a circle. It doesn't matter the size of the circle. Okay, the circle could be really small, it could be really large. Okay, it still takes 6.28 radian measures to go all the way around. Okay, no matter the size of the circle at all. The radius could be 1,000 meters long, or it can be 0.1 centimeters long. It'll always take 6.28 radian measures to go around. This is the definition of what a radian is. Okay, do you need it in order to do today's homework? No, you don't need to know the definition, but you're going to see the word radian measure. That's what they're talking about. Go ahead. Go ahead, yeah. So, all right, let's go back. Let's take it back to what you guys need to know for sure today. Now, let me show you the instructions just so you can see. They want us to convert degree measures into radians and radian measures into degrees. So go back and forth. If they give you a degree measure, then you should be able to write a radian measure. Okay? Thank you. If they give you a radian measure, then you should be able to write a degree measure. You can go back and forth. Okay? The way we do that is using 2 small formulas. So let me show you these 2 formulas. So the first formula here, degree to radian. Okay, this is going to be the first one. So what you're going to do is they're going to give you a degree. How do you know what they gave you as a degree? It has the little degree symbol on it. Okay, that little like circle. Let me show you really quick. Notice number 4 is a degree, 300 degrees. But notice number 3, 11 pi over 9. I don't see a degree symbol. So that means it's a radian. So if there's no degree, it's a radian. If there is a degree, then it's a degree. All right? So for your formula, you're going to write your degree times pi over 180 degrees. That's going to equal to your radian. Okay? So you're going to get whatever degree they give you, and you're going to multiply it times pi over 180. Now, I am going to give you a hint right here. Don't multiply the pi. Leave the pi alone. So your answer should be like 5 pi over 3, 7 pi over 9. Okay, there should be a pi there. Don't multiply it out. But that's basically it right here. This piece is the formula you need to know in order to go from degree to radians. Okay, that's the formula. Now, to go from radians to degree, we're going to go radians times 180 degrees over pi. That's equal to your degree. So you're going to get your radian measure times 180 over pi. So that's going to be your main equation. Okay? So we're going to do 4 examples. You're going to notice it's not that hard to do. If you have a nicer calculator, some of the newer ones, this will be really nice and easy. If you have an older one, I'm not sure if it'll work really nice and easy, so it'd be really good for you to check. Because if it's not working really nice and easy for you, you might want to borrow one of mine here so you can get your homework done easily. Okay? I'm going to do everything by hand though, so I'm not going to use a calculator. But if you happen to have a calculator with you, I would tell you bring it out so you can do some of these calculations so that you make sure you know how to do it on yours. Okay? So here we go. Question number 1. It's a degree, right? 390 degrees. So since it's a degree, I want to change it to radians. So 390 degrees times, now to convert to radians, you use pi over 180 degrees. Well, if I multiply that, again, I'm doing this by hand, so I'm not like trying to take any shortcuts here. I get 390 pi over 180. Now, you see how both numbers end in zeros? I can cancel that out because that's like if I divide it by 10. Okay? So I'm going to end up with 39 pi over 18. What number can divide 39 and 18? Anybody know? 3. Yeah, 3 will work. 39 divided by 3 is 13. 18 divided by 3 is 6. Here's your answer. 13 pi over 6. That is your radian measure. Now sometimes they put like rad like that, but obviously our answers don't have that. But you don't have to write the radian part, but sometimes they will write it, okay, or radians. So it just depends on the book. So this is how you convert an angle in degrees to radians. Okay, now let's change an angle from radians to degrees. So look at question number 2. Notice this one doesn't have a degree symbol on it. It's just pi over 4. Okay, so I want to change it from a radian to a degree. So I'm going to get my radian measure, pi over 4. Okay, and I am going to multiply it by its conversion. Okay, in order to make a radian into a degree, you multiply by 180 degrees over pi. Okay, so you're going to multiply by 180 over pi. Now, the pi's will cancel. So all you have left is 180 degrees divided by 4, which is 45 degrees. And there you go. We just converted a radian into a degree. Notice, I didn't need to know that whole business about like this is how many pieces go around a circle or anything like that. I didn't need to know that. Okay? I just needed to know the conversion factor. Okay? That's all I needed to know. So, this was radian to degree. So let's just do one more of each really quick. Let's go to number 3 and then number 4, and then we'll be done. I'll let you guys do the rest of the problems. There's a total of 12, so I'm doing 4 of them for you. I figure I don't need to do more. They're not that bad. So this is 11 pi over 9. This is a radian. So that means they want me to change it into a degree. So I'm going to multiply by 180 degrees over pi. Remember, it's either 180 over pi or pi over 180. It depends on what you want. If you want degrees, then you want the degree on top, 180 degrees. If you want radians, you want the pi on top. Okay, but you're always going to be using 180 and you're going to be using pi. Okay, so the pi's will cancel. And 11 times 180, I'm only doing this because I'm doing this in my head. I don't know what 11 times 180 is, but I do know that 180 divided by 9 is 20. And 20 times 11 is 220 degrees. I showed you guys the trick with multiplication by 11s, right? Did I? I don't remember if I did. I know I showed somebody, so I'll show you guys after. But yeah, it's a nice little trick. That's why I went 11 times 20. So that was pretty easy to do. So there you go. One more. Let's convert 300 degrees into radians. So 300 degrees times, since I want radians, I'm going to put pi on top over 180 degrees. So that's 300 pi over 180. I did get a question earlier. They said, where did the degrees go? Like, I noticed you had 300 degrees and 180 degrees, but then when you wrote them together, your degrees disappeared. What happened? My units canceled. Because degree on top, degree on bottom, the units canceled out. If you've taken biology or physics, when you guys did those lessons on unit conversion and all that stuff, you guys noticed like feet and feet would cancel out. You would get meters, you get other stuff, right? That's basically what's happening here. The units canceled out. Now, 300 over 180, I can divide by 10. So that'll give me those zeros out of the way. This will be 30 pi over 18. I can divide that by 6, right? 30 and 18 can be divided by 6. So this will be 5 pi over 3. Right here. And like I said, some people would like to write rad. You don't have to. I'm used to writing rad sometimes because they'll use that in calculus, but you don't always have to do that. Okay? So this is what your homework is based on.